The digital relay output on the WEG CFW300 variable frequency drive defaults to sending out a no fault status. That is, it's active as long as there's no fault. Can you change that to indicate something else? Sure. I have an indicator wired like this into the normally open contact on digital relay output 1 so we can see what the output's doing. Let's do a factory reset so we're starting from a known configuration. And sure enough, the indicator's lit, telling us there's currently no fault. Exactly what we expect. This is the free WEG programming software, or WPS. It isn't connected to my drive right now. I'm just going to use it as a quick parameter lookup tool. If we select all parameters and then search on DO for digital output, we see that digital relay output 1 defaults to no fault. How about we change digital relay output 1 to indicate when the drive is running? Looks like we need to put an 11 in parameter 275. Again, this software isn't currently connected to the drive, so I'll go to the drive, scroll to parameter 275, and enter an 11. When I hit run, sure enough, our new run indicator lights up. Let's do another one. There are a couple frequency monitoring options. Let's have the light turn on when the output frequency reaches the requested reference frequency. F star is the requested reference frequency over here before ramps, limiting, etc. are applied. F is the final output frequency. Well, we want to know when the output frequency, F, reaches the requested reference frequency, F star. So we want number 4. So I'll go back to parameter 275 and change it to a 4. The acceleration ramp defaults to 5 seconds. That's 5 seconds to get to 60 Hz. That's a good number for this demo, so we don't need to change that. Let's set the frequency we want to ramp to 30 Hz. That's parameter 121 because we're using the keypad for frequency reference entry. So I'll change that to a 30 Hz. So we expect the drive to ramp up to 30 Hz over 2.5 seconds, and when it gets to 30 Hz, the indicator should turn on. Let's try it. If I hit run, 1,000, 2, 1,000, bingo. The indicator turned on when the output frequency reached the reference frequency. Perfect. We can also have the digital relay output turn on when the frequency gets above some value we set, which WPS calls FX. If we search on FX, we see that we can set both the value and the hysteresis. Fx is the value or threshold we want to exceed. The hysteresis says you must exceed the value by this much for the light to turn on, and this much for it to turn back off again. That way, if your frequency output is bobbling around a little bit due to load changes, it won't keep tripping the indicator. Let's try that. Let's go to parameter 281 and set the frequency we want to exceed at 15 Hz. And we'll leave the hysteresis at half a hertz. Okay, go back to parameter 275 and tell the digital relay output to go active when the output frequency is greater than or equal to the 15 Hz we just set. And let's go back to parameter 121 and set our keypad reference frequency to start at 3 Hz. So we expect to see the light turn on when we hit 15.5 Hz and turn off when it falls below 14.5 Hz. Let's try it. If I hit run and scroll down to the frequency display parameter, we see that the drive's running at the 3 Hz we entered. I'll scroll to 15.5 Hz, and sure enough, the light turns on. Now I'll scroll down to 14.5 Hz, and the light turns off. Exactly what we expect. Perfect. There are lots of different things the digital relay outputs can be used for. Is the reference frequency above the threshold? Is the output frequency above or below a threshold? Is the reference frequency equal to the output frequency? And you can do similar things with current and torque. You can indicate if the drive's in remote mode, if it's running, if there's faults, etc. This drive gives you lots of options, so use them to your advantage. So after the factory reset, all we really did was tell the digital output what we wanted it to do. And for some of the functions, we needed to provide a frequency level to compare against, and we found that we could even use hysteresis if we wanted to. And while we didn't do it in this video, there are similar comparison levels for the current and torque monitoring functions. And of course, we also entered and viewed the reference frequencies using these guys. Now, while the default motor parameters worked for this demo, you should be sure to enter your motor parameters in these guys to get the best possible drive performance. Well, that ought to be enough to get you going. Click here to learn more about the WEG CFW300 drive. Click Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new videos.